Alright, next topic, spring forces. We can use Fs to represent spring forces. For calculating Fs, we can just use Hooke's law, or Fs, the spring forces, is equal to negative k. The k is spring constant, times x. The x is the distance that spring got stretched, or the delta x of the spring. The delta means change. Y'all probably knew that. So let me give you an example. This is a ceiling. This is a spring. Without hitting the object, the original length of the spring is x. When it hits an object, you know, if the spring is hitting the object, it was stretched. The length of the spring becomes x x2, and the original length is x1. And when it is asking you the spring forces, it is Fs times Fs is equal to negative k, the constant of the spring, times negative times delta x. Delta x of the spring is x2 minus x1, which this is delta x. And that's it. That's how you got the spring forces. And now you may ask, why there's a negative here? Well, let me tell you. Let me give you the definition. The spring force is always directed opposite to the direction of the applied force or displacement. Why? Let me just use this example. Get this example over here. Let's draw a free body diagram of this object. The object is has a gravitational force, which is Fg. And the spring, because it is at rest, it's at equilibrium, it definitely has a force which is opposite its direction, which is pointing upward, which is Fs. This is the spring force. That's why it got the opposite direction. In this situation, Fg is the applied force. Applied force. And spring force is directly opposite to its direction. So yeah, that's why there's a negative here. Also, it is negative to the displacement because originally it is right here, and now the length of the spring is like over here. This is the direction of the displacement because it starts from here and then finally it reached here. So it's opposite the direction of the displacement. So it's also pointing upward. So it's supposed to point upward. So this is why these are the two explanations for why there's a negative over here for the spring force.